All right, Chapter 2, Inductancy. The important points of the chapter summarized below. Study the information containing the information foundation of later chapters. Inducting the characteristic of the electrical circuit with the pole of the chain of the current. Um, the relationship opposition called the creation distinct destruction of magnetic field with current starts the flow of magnetic lines of force are created. Lines of force over the conductor inducing the counter EMF in the direction of the opposing of that opposed to the current. And inductancy opposed to the angle of the change of the current is the current inductancy. When the current is increased, the inductancy try to hold down, show the current in the inductancy. When the current decreases, the inductancy tries to hold it up. Self-inducting process which the circuit induces EMF into itself alone with the move of the magnetic field. All electrical circuits must possess the self-indicated opposition inductancy, however, to take place within the charge of the current when the inducer does not oppose the current. Only with the change of the current, the property of the inductance can be increased by forming the conductor into a loop. And in a loop, the magnetic lines of force are affected with more of the conductor at one time. This increases the self-induced EMF. So you have your direction magnetic field, left-handed rule, induced voltage going with the finger pointed straight. Your middle finger, the direction of the relative of the current of the motion, direction of the flux expansion, flux expanding conductor 1, current conductor 2, and induced EMF, which happens in conductor. This switch is closed, current switch closed, and the current increasing. Direction of the magnetic field also changes with the middle finger and induce the voltage direction of the relative of the counter conductor motion. This shows the direction of the flux, to left and right, A and B, I believe can. Inductance, the coil. The property inductance can be further increased by the conductor in form. The coil, the coil contains more loops, the more of the conductor can be affected by the magnetic field inductors. Inductors coils are classified according to core type. The core material is known either as air or soft iron. Know that the factors affecting coil inductancy, the inductancy of the coil indirectly dependent upon the physical construction. Some of the factors affecting the inductancy are the number of turns in the coil. Increase the number of the turns will increase the inductancy. The coil diameter increases directly cross sectional over the area of the coil diameter. The inductancy increases directly over the cross sectional area of the coil. Length of the coil when the length of the coil and length of the coil is increased, keeping up with the number of the while keeping up with the number of turns the same, the turns and is spacing increased, and the decrease is in inductancy of the coil. Type of the core material increases the permeability of the core resulting in inductancy of the coil. So, closely wound, widely spaced. Air core goes through the center, goes soft iron core. When the coil's in layer, more layers deep with the form of the coil, greater effect of the magnetic field of the conductor layer of the coil can increase the inductancy. Shows A, B, iron core. Unit inductancy L. Inductancy L is measured in henries. Inductor has an inductancy of 1 henry if the EMF of 1 volt is induced in the inductor of the current through the inductor changing at a rate of 1 ampere per second. So EMF of 1 volt induced in the inductor current through the inductor changing at a rate of 1 ampere per second is a henry. Common units of inductancy are henry or millihenry and microhenry. I believe 1 million henries, 1 million equal to 1 henry. Growth decay when the current of the resistant inductancy resistant current of the required with the current of the inductor will decrease to 63.2%. Maximum current decrease to 36.8%. The maximum current or decrease is 36.8 or 36.2. Maximum 36.8. Of the maximum current is known by the time of the constant. The letter is the symbol for the LR. Remember the delta symbol is the triangle. The letter symbol for the load inductancy resistant time constant is inductancy in henries over ohms, or his formula is in T in seconds is the is equal to henries over ohms, or in microseconds henry and micro henries in ohms. or the time constant is in the load resistant current circuit is also made to define with the time required by the current in the conductor with the growth of the decay of the final value of the continue with the growth of the decay with the initial rate. For all practical purposes, the current is inductor reaches the maximum of 5 time constants. Decreases to 0 and 5 time constants. Alright, power loss in an inductor. Since an inductor coil contains a number of turns of wire, all wires have some resistance. The inductor has a certain amount of resistance. Resistance is usually a very small, negligible effect of the current. However, the power loss of the inductor, main power loss of the inductor, or the copper loss, hysteresis loss, and eddy current. One is eddy current with the heat. Hysteresis loss is the backward motion. Copper loss can calculate with the multiplying square of the current with the resistance of the wire over the coil, or ampere over ohms. The hysteresis loss is due to the power consumed of the reverse of the magnet of the core of each type of the current directed. Eddy current is due to the heating of the circulating currents increased in the iron core magnetic field of the coil. Mutual inductance. Two coils are located with the flux from one coil cut the turns of the other coil with the coils of the mutual inductancy amount with the mutual inductance depend on the several factors of the relative position axes of the two coils of the permittable of the cores, physical dimension, two coils with the number of coils in each for the coil, the distance between the coil with the coefficient coupling K specifies or is coupling is marked with symbol is K. Series amount of the specific amount of the coupling between the coils. If all the flux through the one coil cuts all of the turns of the other coil, the coefficients of coupling is 1 or unity. If none of the flux of one coil cuts turns of the other coil, if the coefficient is 0. The mutual inductancy between the inductor coil 1 and inductor 2 may be expressed mathematically as mutual conductancy is equal to the coupling times the square root of the inductor coil 1 times the conductor coil 2. Inductors close. Inductors close. The large mutual inductancy inductors far away. Small mutancy inductors. Inductors in perpendicular. Their axes are perpendicular. No mutual inductancy. Alright, computing the inductancy of the circuit. The total inductancy of the circuit they compute with the individual inductive of the value of the tree with the same resistance value of the inductancy of the inductors or series are likely resistance and resistors in the series. So the load total, the resistance, the inductancy total is in henries is equal to the henries of the inductor coil 1, 2, and 3 and the number added together in the series. The inductancy inductor physical a combination mathematically like the resistor of the resistor in parallel. Also, that be your inductancy total in henries is equal to 1 over the in a parallel circuit is equal to 1 over the given one over the inductancy coil 2, 1 over plus the 1 over the conductancy. Add all the conductancy together and the specific number of inductancy coils over 1 over 1. Both above formulas are accurate, provided there are no mutual inductancies between the inductors. And that was chapter 2's summary. Chapter 3, capacitance.